Welcome to ICSE Chemistry Hub. Hope you all are doing well and you all are studying for your upcoming exams. Today, we are going to start with Lecture 5 of the Periodic Table series. And the topic that we are going to discuss today is called as electronegativity. Am I clear, children? So without any delay, let's dive into it. But before we start, let's quickly revise about what are the various periodic trends that we have discussed. We had already finished with the first atomic trend, that is atomic radius or atomic size. It is the size of the atom from the center of the nucleus to the outermost shell. Then we had discussed something called as ionization potential. I had asked you to remember it in terms of energy. So it is the amount of energy that is required when we need to remove an electron from the outermost shell. The third one, that was electron affinity. Again, I had asked you to remember it in terms of the word attraction. So remember electron affinity as electron attraction. Potential, the amount of energy will be required. And for affinity, it will be the amount of energy that will be released to add an electron or to accept an electron to an isolated gaseous atom. All these periodic trends I have explained in detail. If you have any confusion, you can have a look at the videos. All these videos, you can have a look at the playlist of my channel at the rate of ICSE Chemistry Hub. So let's start with today's topic. So today we are going to discuss about electronegativity. What is the definition of electronegativity? Second thing, we are going to discuss what are the factors affecting electronegativity. Then we will be discussing the trends. That is, how does electronegativity vary across a period and down a group. And then at the end, without fail, please do have a look at the important questions that were asked in the previous year board papers, because once you finish a topic, you will get an idea about how board people are going to ask the questions related to this. So let's start with today's topic, the important periodic trend, that is electronegativity. Okay. Now children, before I start with the definition, I just want you to answer one thing for you. Can you tell me who will be electronegative in nature? Will it be metals or will it be non-metals? Yes, we know that metals are mostly electropositive, and so whenever I use the word electronegative, I know that my non-metals are going to be more electronegative. So this is one of the questions that is asked in the board papers, that who do you think will be more electronegative? Will it be metals or will it be non-metals? Always keep in your mind, metals are positive whereas non-metals are negative. So if the question is who is more electronegative, definitely it will be non-metals. Okay. So now let's start with the definition. What is electronegativity, children? It is the tendency of an atom to attract the shared pair of electrons towards itself when it is combined in a compound or in a chemical bond. Okay, once again children, let us read the definition. It is the tendency of an atom. Okay, for example, here they have given you an example of a compound or a molecule called as HCl. What is HCl? HCl is nothing but hydrogen chloride. Okay. Now we know hydrogen is a metal, chlorine is a non-metal. So whenever you have two non-metals together, which type of bonding will usually happen? Yes, we know there will always be a covalent bond that will be formed. When I say covalent bond, I mean it takes place because of sharing of electrons in it. Yes or no? Okay. Now have a look here, children. Hydrogen has an atomic number of 1. Chlorine has an atomic number of 70. So it will have 7 electrons. It will be 2, 8, 7. Hydrogen wants to complete its duplet and chlorine wants to complete its octet. So what do they decide? They decide that let's come together and share our electrons. Yes or no, children? That is why sharing of electrons is called as a covalent bond. Clear? So in this compound called as hydrogen chloride, they are combined in the form of a compound, or they have formed a covalent bond or a chemical bond. Okay. Now how does they attain an octet? Hydrogen has 1 electron, chlorine has 7 electrons. They decide to share 1 electron each. Hydrogen contributes 1 electron, chlorine contributes 1 more electron, and they form a covalent bond. So actually, if I draw the diagram, the shared pair of electrons should be somewhere in the middle. Yes or no, children? Okay, why? Because hydrogen has contributed 1 electron, chlorine also has contributed 1 electron. But here, the more non-metallic element, if I say hydrogen and chlorine, hydrogen is also a non-metal, chlorine is also a non-metal. Can you tell me which is the more non-metallic compound here? The more non-metallic compound is chlorine here. So what does it do, children? It is the tendency of an atom to attract the shared pair of, they are sharing the electrons, but these electron pair will never be placed in the middle. Okay, it will shift more. This shared pair of electron is going to shift towards the more electronegative element, or we can say the more non-metallic element. Okay, so can you see here what is going to happen? The shared pair of electron is going to shift more towards chlorine. Okay, that is what exactly electronegativity is. Okay, the tendency of an atom here, chlorine atom, is going to pull the shared pair of electron towards itself. So how will the diagram going to become, children? The shared pair of electrons are going to be more towards chlorine. Yes or no, children? Though both have contributed 1 more electron, but the whole electron pair shifts towards the more non-metallic element, which is chlorine. Clear? What is the definition, children? It is the tendency of an atom to attract the shared pair of electrons towards itself. The more non-metallic element will pull the electron towards itself. And I just now told you, elements with high electronegativity, who will be more electronegative, more non-metallic element will be the electronegative element. So high electronegativity means they are more non-metallic. Am I clear till here, children? Okay. So once again, it is a measure or the tendency of an atom to attract, okay, it is trying to pull the shared pair of electrons towards itself. But when does this happen, children? Now, please remember here, electronegativity is a relative term. Am I clear? What do I mean by the word relative? It is between 2 or more atoms. Electronegativity can never be applied. Okay? You can never apply electronegativity towards an individual atom. Okay? Electronegativity is always a relative term. Whenever there are 2 atoms competing for pulling the shared pair of electron, the more non-metallic element will pull the shared pair of electron towards itself. So it is a measure or a tendency to pull or attract the shared pair of electrons towards itself. But this happens only when it is in a molecule of a compound. Okay. For example, you know this covalent compound. Which is this covalent compound, children? It is water. There are 2 hydrogen atoms and there is 1 oxygen atom. Okay. So they have shared their electrons and they have formed a covalent bond. Can you tell me which element or which atom will pull the shared pair of electron more towards itself? Yes, we know that oxygen is more electronegative, or it is more non-metallic in nature. Hydrogen is also a non-metal, but this is less non-metallic, whereas oxygen is more non-metallic. So what is it going to do, children? It is going to pull the shared. Oxygen is going to pull the shared pair of electrons more towards itself. Am I clear? So oxygen is the more electronegative element here. Clear? So now let's start with what are the factors which affect electronegativity, or what are the two things on which electronegativity depends. Like all the periodic trends, it depends on two things. The first one is atomic size, and the second one, as usual, is nuclear charge. As the atomic size increases, for example, let's say we have two atoms. One is X and the other one is Y. Okay. Now what is electronegativity, children? We know electronegativity is the tendency of an atom to attract an electron. Which one do you think will be able to attract the electron more easily? It will be, of course, this atom X. Yes or no? So remember this, the smaller the atom, more closer is the nucleus to the electron, more effectively it can attract it, it can pull the electron. But as the distance increases, as the distance between the nucleus and the electron increases, what is going to happen, children? It is going to be difficult for this atom Y to pull the electron or to attract the electron towards itself. Clear? So please remember this. As the atomic size increases, as the size of the atom keeps on increases, the nucleus is becoming more farther away from the electron. So the electronegativity, the tendency to pull the electron, the tendency to attract the electron is going to decrease. As the size increases, the tendency to attract, the tendency to pull the electron is going to decrease. Okay. The second factor is nuclear charge. Who is going to give me the nuclear charge, children? I've told this many times. It is the atomic number. Okay. More the atomic number, more will be the nuclear charge. As the nuclear charge increases, more powerful the nucleus, more will be the ability to pull, or more will be the ability to attract the electron. So what happens to the electronegativity, children? The electronegativity will increase. Clear? So more powerful the nucleus, more powerful the nucleus, more will be the pull or more will be the attraction. So the tendency to pull an electron towards itself will also increase because the nucleus is now more and more powerful. So what are the two factors on which electronegativity depends, children? The first one is atomic size and the second one is nuclear charge. Let's start with the trends now. Let's see how electronegativity differs across a period. When I say across a period, I mean from left to right. What is the meaning of the word electronegativity, children? Electronegativity means moving from left to right. Again, what are the two factors on which electronegativity depends? Electronegativity depends on atomic radii or atomic size, and the second one is nuclear charge. Now we know from left to right, the atomic size decreases. Yes or no, children? We know this trend that atomic size from left to right is going to decrease. More smaller the atom, yes or no? More smaller the atom, more will be the ability to attract or pull the electron. So what happens to the electronegativity? The electronegativity will increase. As the size decreases, the nucleus is very much closer to the electron. So what happens here, children? The electronegativity will increase, more electrons. Am I clear? The second one is nuclear charge. Who will give me the nuclear charge, children? It is the atomic number. Hydrogen has an atomic number of 1. Helium has an atomic number of 2 when I move from left to right. Lithium has 3, 4, 5, 6, 7, 8, 9, 10. So what is happening here, children? More powerful the nucleus is becoming. Yes or no? So the nuclear charge is increasing. When I'm moving from left to right, more powerful the nucleus, more will be the ability to pull or attract the electrons towards itself. Am I clear? So as the nuclear charge increases, more will be the ability to pull or attract the electrons. So electronegativity will increase. Here also electronegativity is increasing. Here also electronegativity is increasing. So overall, from left to right, electronegativity, we usually denote it as En, will increase from left to right. Please remember this. This is same trend just like ionization potential, electron affinity, and now the third one is electronegativity. They all three follow the same trend. From left to right, ionization potential increases, electronegativity increases, electron affinity will increase from left to right. Next, you need to remember certain points when you are learning electronegativity. Okay, if we have already discussed in a period, that means from left to right, what is happening to electronegativity. Okay, electronegativity means the tendency of an atom to attract or pull the electron towards itself is called as electronegativity. Please remember, noble gases are not at all electronegative. They are not non-metals at all. Am I clear? So please remember this point. This is a very, very important thing that you have to remember. Noble gases are not electronegative. They do not attract, they do not pull the electron towards itself. They are not at all interested. They are happy in their own world. So noble gases do not have any electronegativity. They do not pull the electron. They do not need an electron. They are not interested in the outside world. They are very much happy with their own self. So if I look at the whole periodic table, please remember this. Fluorine is the most electronegative element. Please remember this. Usually halogens will have high electronegativity because they are the most non-metallic element. I had already told only more non-metallic elements will be more electronegative. They will be more negative in nature. So please by heart this, which is the most electronegative element. It will be fluorine. Clear? So I hope these 2 points are clear to you, that noble gases are not at all electronegative and fluorine is the most electronegative element. Now let's start with the last trend, that is how does electronegativity vary down a group. That means when I go from top to bottom, how does the electronegativity vary? What are the 2 factors, children? The first one is atomic size. We know as I am going from top to bottom, as I am going from top to bottom, what is happening to the atomic size? The atomic size is increasing. Am I clear? For example, if I take hydrogen, lithium, sodium, from top to bottom, the atomic size is increasing. More larger the atom, more far away it is from the electron. Can you see here, children? Sodium is very, very far away from the electron. So the pull, the ability to attract, the ability to pull the electron will decrease. Am I clear? So as the atomic size increases, the tendency to pull or the tendency to attract the electron will decrease. Clear? The next one is nuclear charge. As the nuclear charge, who will give me the nuclear charge? The atomic number. For example, hydrogen has an atomic number of 1, lithium has 3, sodium has 11. So what is happening here, children? More powerful the nucleus is becoming more and more powerful. More powerful the nucleus, more powerful the nucleus, it should actually increase. So here there's again a confusion. One place, because of atomic radius, it's telling it should decrease, and the other place it is telling that the atomic number should increase. Now when there is a confusion like this, at one place it's decreasing, one place is telling me that it should increase. By now you should have become an expert now. You should be able to decide which factor will dominate. Always remember, nuclear charge is not at all given a priority here. So we cancel out this effect. Am I clear? Remember this sentence, increase in atomic radii dominates over increase in nuclear charge. Always remember, nuclear charge is not given importance, is not a priority here. So this effect cancel out. So overall down a group from top to bottom, what happens to the electronegativity, children? It decreases. Yes or no? Electronegativity from top to bottom decreases. Clear? So now this is the trend that you should. Electronegativity, just like ionization potential, just like electron affinity, it follows the same trend. Left to right, it increases. Top to bottom, it decreases. Clear? So in the exam, if they ask you which is the most electronegative element, it should be somewhere here. Noble gases are not at all electronegative. So the most electronegative element will be fluorine. And the least electronegative will be some metal, of course. Okay, so you will go to group 1A. It is the most metallic elements here, but it will not be francium. Why not? Because francium is a radioactive element. Not much studies have happened of this element because it gives out radiations. It's a highly radioactive element. So in the exam, if they ask you which is the least electronegative element, it is going to be cesium because it's a highly metallic element. Am I clear? So which is the most electronegative element, children? It is fluorine, and the least electronegative element is going to be cesium. Let's now look at some important questions, and you yourself try out, children, if you are able to answer it after watching the video. The first question is, when moving from left to right. When I say left to right, I mean I am moving across a period. For the below property, choose the electronegativity. We know electronegativity from left to right always increases. So left to right in a period, electronegativity or the tendency to attract or pull the electron will increase. The next one, the element below sodium in the same group, the element below sodium, sodium is here. Which is the element that is below sodium? Hydrogen, lithium, sodium, potassium. So they are talking about which element, children? They are talking about potassium. The element below sodium in the same group should be expected to have a, they are simply asking, down a group. What happens in a group? Down a group, what happens to the electronegativity? We know it decreases. So the element below sodium, that is potassium, will have a higher or lower, children? Yes, we know it will have a lower electronegativity as compared to sodium because from top to bottom, electronegativity decreases. Next one. Please remember this. This is asked in the exam many times. Mr. Metals are very good reducing agents. You have to learn this, children. Metals are very good misters. What is the meaning of mister? They are very good reducing agent. When I say reducing agent, because they are electron, we know metals will always donate electrons. That is why they get that plus sign. Am I clear? Metals are very good donors. Clear? Next one. Arrange the elements as per the instructions given in the bracket. Now children, whenever you get a question like this, remember, never use these signs. Do not use these signs. Am I clear? You always have to separate them with a comma. Okay? There are some elements given: cesium, sodium, lithium, potassium, rubidium. Now, if you know, these are lithium, sodium, potassium, rubidium and cesium. This is nothing but Downer group elements. Yes or no? They are in a group. All are metals and they fall in a group. We know it is decreasing electronegativity. We know from top to bottom, electronegativity will decrease. Yes or no? Top to bottom, electronegativity decreases. So the same series, which will have the highest, should be written first. Lithium has the highest electronegativity, followed by sodium, followed by potassium, followed by rubidium, followed by cesium. So what's the correct order, children? Lithium, lithium has the highest, cesium has the least. Lithium is the highest electronegative element, followed by sodium, potassium, rubidium, and the least one will be cesium. Okay, next one. The tendency of an atom, this is a definition of, to attract the shared pair of electron towards itself is nothing but search for the answer, electronegativity. Okay, again, which element has the least? These are very frequently asked questions. Which element will have the highest electronegativity? It has to be somewhere in a period here. Yes or no? Left to right. So, noble gases they do not have any electronegativity. So, it is fluorine. Which element has the highest electronegativity? It's fluorine. Which has the least electronegativity? It is going to be cesium. Am I clear? So, highest electronegativity is for fluorine and the least electronegativity is going to be for cesium. Am I clear? So, this was all for today's video. Please stay tuned for the upcoming next video. That is going to be our last part on periodic table. The last periodic trend, that is metallic and non-metallic elements. So, please stay tuned. Keep learning, keep revising. Please do share your valuable feedback to us because we will be getting a chance to improve ourselves. Thanks a lot, children.